Hello, and today we're going to be talking about advanced trigonometry and how it relates to the unit circle. So this is the unit circle here, and what the unit circle is it's a circle with radius 1. So this length here is just 1. So let's just label that so we can get that out of the way. So this radius 1 circle is really powerful at working out trigonomic ratios because because of this radius of 1 we can draw triangles in it, and we know that the hypotenuse always has to be 1. So I'm going to draw a line here, and let's say it's an angle theta. So this distance here has to be 1, and there's an imaginary line here. So if I wanted to work out the sine of this value theta here, well, I can use this triangle here to work it out. So sine of theta, SOHCAHTOA, let's put that down. SOHCAHTOA, sine is equal to the opposite, this length here, divided by the hypotenuse, 1. So what we get is sine of theta is equal to this value here. So if you haven't noticed, I've got an x and y here, so this distance going up is effectively just our y value for this particular point here. So if this distance here is the opposite, which is equal to sine of theta for this particular theta, then our y coordinate for this particular point is going to be sine of theta. So now let's look at the cosine now, and we're going to look at this distance now because this is adjacent to theta. So cosine of theta is going to equal to the adjacent over the hypotenuse, 1. So it's just equal to the adjacent. Well, again, we're on the xy plane, so just how far this distance is across is just going to be our x value for this point right here. So we can say that this x coordinate is cosine theta. So now that we have this special relationship, we can start to use it to find we can use it to see what happens if we change this angle theta and see if we can form some sort of relationship between cosine and sine and all these other values. So we have cosine and sine, but where's tangent in all this? Well, tangent is actually a line that goes through one point of the unit circle, and that particular point for this angle theta is that point right there. So what tangent is saying is what is the slope of this line here, and we'll not go into that ever again because the main point of this video here is the relationship between sine and cosine. So let's start playing around with our angle theta. First thing that I want to do is I want to get the sine of 180 minus theta. I want to know what that equals. Well, we can just draw this on our unit circle. It's going to be around about there. And we can draw a line straight as I can there. off into the distance, and if we want the sine, we want the y value of this point here. Well, in relation to this line here, it's the exact same. So what we're dealing with here now is effectively this blue angle here, 180 degrees minus theta. And now we're starting to see that this is the exact same as sine theta. We can make another right angle triangle. This can be 1, and we can call this theta here, and we can derive the same result. Well, okay, what about cosine of this new angle here? Now if we want the cosine of 180 degrees minus theta, what does that equal? Well, again, these two triangles are the exact same. They're just on a different side of the Cartesian plane. So, this distance here is the same distance here, but it's negative. So if it's going to be negative, the same distance here but negative, this value here must equal negative cosine theta. So that's all nice. We have two very nice relationships. But what else can we do with this unit circle? Well, let's see if we change our angle theta again. So here's our unit circle again. And we're going to change theta again. And we're going to get the sine of 90 degrees plus theta. So what does that look like? Well, let's use our unit circle again. So 90 degrees, so we want an angle that's 90 degrees straight as possible, off it goes. And if we want the sine of this new angle, well, we know it has to be the y coordinate. So if it's going to be the y coordinate, we want this value here. So how are we going to find this? Well, again, we can use the unit circle to help us. What we've essentially found, we know the hypotenuse, we know that this is a right angle, and if we know that this is 90, and this full angle here is 90 plus theta, then we can claim that this angle here, this inside angle, is just theta. So if we can use theta to work out this adjacent side, then we can find out what sine of 90 degrees plus theta is. So what deals with adjacent? Cosine. So cosine of theta, again the hypotenuse, that's just going to be cosine of theta. So now we have a very interesting relationship between two trigonometric ratios. If we just get an angle and plus 90, it's going to be equal to, if we get an angle plus 90 degrees and want the sine of that angle, well, we can just say, well, that's equal to the cosine of whatever that angle is. Can the same be said with sine then? Can we say that if we use cosine instead, we want to find out cosine of 90 degrees, plus theta. What is that equal to? Well, we can use the same logic. We know that's 90. We know that this is theta here. And what we want this time is the x value of this particular point. That's the same as this line here. And we can say that that's the opposite of theta. And we can now say that this has to be equal to sine theta. So that's all the time that I have for Advanced Trigonometry Part 2. If you have any questions, feel free to ask me in the comment section below or contact me in social media, and I will see you in the next video.